And the important part when you have these questions is to know when you're thinking of money and when you're multiplying. You are multiplying when there's absolutely no sign between the terms. So right here, you're multiplying. Number 4, you're multiplying because there's nothing between the terms. Number 5, you're multiplying. There's nothing between the parentheses. If there's something between the two terms, then you're thinking of money, right? And if there ever is a minus minus, you have to change it to plus plus before thinking of money. So right here, we're multiplying, and 4 times 2 is 8, and a positive times a negative is a negative, so that's negative 8. Negative 4 minus 2, you got to think of money. Negative 4 means that you owe $4. Negative 2 means you owe $2. So what's your answer? Negative 6, you owe $6. Before thinking of money, you have to change your minus minus to plus plus. And again, you are thinking of money because there's a sign between the terms. So yeah, if you owe 4 and you have 2, you're going to owe 2, negative 2. Number 4, we are money or multiplying? Multiplying. So what's negative 4 times positive 2? Negative 8, right? It's just 4 times 2, 8, and a negative times a positive is a negative. The only time you get a positive answer when you're multiplying, a negative times a negative. Or back in the 3rd grade, 2 times 3 is 6, right? Positive times a positive, that's also a positive. But yeah, negative times a negative equals a positive. If the signs are different, the answer is going to be negative. So yeah, 5, you have a negative times a negative, you get a positive 8. 6, are we multiplying? No, we're thinking of money. So what does this mean?
That you owe $4 and you have $2, so you don't owe negative 2.
Yeah, you owe 4, you have 2, you're still going to owe 2. Number 7, am I thinking of money or multiplying?
No.
Is there a sign between them?
Yeah, there is.
There is, so you are thinking of money. What does this mean?
Negative 5.
You owe 3, you owe 2,
and together you owe 5.
together you owe 5. Total of 5. Number 8, are we thinking of money?
Yes.
Yes. Now remember, plus sign doesn't mean add. Plus sign means that you have money. So right, so you owe 3, you have 2. How do you end up?
Negative 1.
Negative 1, you owe 1, right? You owe somebody $3, you only have 2 to pay him, right? I mean, you can't completely pay him off, but you could give him the $2 that you have and you still owe him $1. All right, last but not least, we actually have 3 things, and there are symbols or signs between all terms, so we will be thinking of money.
So the negative 2 goes into a positive 2 because there's a negative for a parenthesis.
That is correct. That becomes positive.
You don't owe nothing.
You don't owe nothing, you don't have nothing, huh?
Yeah.
So you owe somebody $5, but you have 3, you have 2, so you have 5. You owe 5, you have 5, you don't have anything left over. 0, a nice whole number. All right, so that's a warm-up. Let's jump to the actual notes. Jot this down, please. Notes 0.5, multiplying and dividing. Now, we've been doing multiplying and dividing, but we're going to be dealing with fractions right now. Fractions, okay? We did kind of start this yesterday, but we're going to start fresh today. Multiplying and dividing fractions. Notes 0.5. Remember, guys, on each page, I need a title. So put this title, note 0.5, multiplying, dividing fractions, and also put the date and the day, right? Title, date, and day on each page of your notebook. We will be turning in the notebooks after chapter 1. We're barely on unit 0 right now. But let's first begin by reducing 4/6. Now, I think we talked about this yesterday. Reducing 4/6 is kind of like dividing both top and bottom by 2. That way your final answer is 2/3. But there's a different way of reducing, which I don't recommend, but it'll help you understand what we're doing today, multiplying and dividing fractions. A different way is to rewrite the 4 as 2 times 2, and then rewrite the 6 as 2 times 3, okay? Now, whenever you have multiplication on top and on bottom, and there's no addition or subtraction, you could actually cancel things out. We know that 2 divided by 2 is 1. 2 divided by 2 is 1, so we are able to cancel those out, and there's our answer. Same answer, it's just reduced in a different way, okay? So why the heck would we want to change the 4 to become 2 times 2 or the 6 to become 2 times 3? That's not practical. It's easier to just say, oh, I'm going to divide both top and bottom by 2, get my answer 2/3. I totally agree with that. But the only reason why we're changing it to multiplication is so that you could understand how to multiply fractions. Because on multiplying fractions, there's going to be a lot of canceling out. Okay, so how about we, let's make some space here for all this. How about we compare 3 plus 2 over 2 with 3 times 2 over 2. Okay, so I want to reiterate that we could cancel when we have pure multiplication, but you cannot cancel when you're adding or subtracting, right? So we already know what 3 plus 2 is. What's 3 plus 2? 5. Okay, so you have $5. If you divide it by 2, are you going to get you're going to get a decimal, right? Because 5 divided by 2 is $2.50, right? 2.50, 2.5. So right here, you cannot cancel 2's because the answer is not 3, it's actually 2.5. So when you have addition, you cannot cancel 2's. But when you have multiplication, check this out. What's 3 times 2? 6. And what's 6 divided by 2? 3. So you could see that when you're multiplying, you can cancel, and you'll get your answer 3. But when you're adding, you cannot cancel. I mean, what's the answer to this guy? The answer is 5 over 2, which is, you guys said 2.5, right? Or 2.5. But either way, we could see you cannot cancel here. The answer is not 3. It's 2.5. Over here, you can cancel. Why? Because there's multiplication. The answer is just 3. Okay? So let's try something else. Let's go ahead and copy down this right here. You see right here we have a fraction, 2/3, times a fraction, 1/2. Now, believe it or not, multiplying fractions and dividing fractions is really, 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 really easy. Okay? You guys are going to love it. You have one of two choices. You could reduce first and then multiply, or you could multiply first and then reduce. It's totally up to you. You guys want to reduce first? Actually, let's do both ways, yeah? Let's reduce first, then multiply. Now, what do I mean by reduce first? Now, anything on top is going to be divided by anything on the bottom. That's what a fraction bar is. It's really a division problem. So right here, yeah, 2 divided by 3. Okay, we can't do that. Yeah, but let's go with the actual numeric answer instead of the decimal answer. Check this out. The 2 up on top is being divided by whatever's on the bottom. So I really have 2 divided by 2. So what's 2 divided by 2? 1. So you could technically cancel out those 2's. You reduced it. 2 divided by 2 is 1. And then you could multiply the top with the top and the bottom with the bottom. So up here you have a 1. Right here is a 1. So 1 times 1 is 1. And then now the 2 canceled though, right? The 2 canceled. So you have 3 times 1, which is what? 3. And guess what? That's your answer right there, 1/3. That's what we call reducing first and then multiplying. But maybe 2/3 times 1/2. Same exact problem. Let's do it the other way. Let's multiply first and then reduce. Now what do I mean by multiply first? Top with the top. 2 times 1 is 2. 3 times 2 is 6. And 2 6, you could now reduce that by 2. And you'll get 1 over 3. Same exact answer. So which one do you think is easier, canceling and then multiplying, or multiplying and then reducing?
I like the bottom better.
Okay, if whatever method you're comfortable with, that's what you want to go with. All right, but I love seeing the same exact term up on top and on the bottom. I just scratch it out and I'm ready to go. Right, the 2's gone. The 2's gone. What's left? A 1 over a 3. There's my answer. Right. So if you want to multiply first, go ahead and then reduce at the end. But canceling is technically reducing first and then multiplying. So I think reducing first and multiplying is a lot easier. You might want to label both works. Like this guy up here, this was reduce, then multiply. And this guy down here was multiply, then reduce. Of course, up here, what do I mean by reduce? I mean cancel out, right? 2 divided by 2 is 1, cancels out. So it's totally up to you on what method you want to do. Let's move on to this guy. Wait, we already did that one, both ways. All right, let's move on to something else. Let's move on to this paper that you received yesterday. So on this handout, we have all the rules that we already know, right? Rules for adding and subtracting, rules for multiplying, or you could think of money and the rules for multiplying. We also have the storyline, but let's jump to this part right here where it says multiplying fractions, because that's what we're focusing in on today. So we said that, it even says right here, you could multiply the top with the top, the numerator with the numerator, and the bottom with the bottom, and then reduce. Or you could reduce first and then multiply, right? And what do I mean by reduce first? I mean by cancel. So, number one, could I cancel anything? No, I cannot. Why not? There's a 1 up here. There's a 2 down here. If there were a 2 here and a 2 up here, yeah, I could cancel 2s. If there were a 3 up here and a 3 down here, I could cancel 3s. Or if there were a 5 up here, I could cancel 5s. But the bottom line is there is nothing alike on top and bottom, right? If you say 3 divided by 2, that's not a nice number. And 1 divided by 5, so there is no possible ways of canceling out. So,
just do the way that you multiply.
Yeah, multiply. Top with the top, bottom with the bottom, what do you get?
3 over 10.
3 over 10. Now, even if you tried to reduce, you can't, right?
You just leave it like that?
You just leave it like that. Now, that makes total sense because we were not able to cancel. That means we were not able to reduce. So, yeah, it makes sense that you're not able to reduce over here. Everybody write down 3/10 right there on number 1. Number 2. What's the easiest way of dealing with this one?
Just cross out the 2. Yeah.
Cross out the 2's, right? So everybody scratch that guy out, scratch that guy out. What's your answer? 1 over 3. But, yeah, negative times a positive is a negative. Remember the rules of multiplying. So negative 1/3. See, it's really easy to multiply fractions. It's a little bit more challenging to add and subtract fractions. We're going to deal with that tomorrow. And we should be ready for the test on Friday. By the way, the test Friday could override your previous quiz score. If you get a better test score, I'll change that quiz score to whatever you get on that test. Let's look at this next one. This one's interesting. Let's begin with what is a negative times a negative? Positive. So you don't even have to worry about it. You know that your answer is going to be positive, all right?
And then you can cross the 9.
You could cross out the 9s.
And then you have 8 over 32, you can simplify it.
Yeah, and now you could write your answer as positive 8 over 32, then reduce. Or you could even reduce the 8 and the 32 right now. Because you could imagine the 8 over 32. You could reduce both of them by 2. Or you could reduce both of them by 4. Or even reduce both of them by 8. It all depends on if you know your multiplication tables or not, right? So if I reduced both by 8, then this would become 8 divided by 8 is 1. 32 divided by 8 is 4. So what's your final answer going to be? 1 over 4. See, it works out beautifully. Now, let's say that you didn't do that. Let's say that you didn't cancel the 8 with the 32 and got a 1 and a 4. Well, then you would say 8 times 1 is 8 and 1 times 32 is 32. So if you didn't cancel, you'd end up with 8 over 32, and you would still have to reduce that, right? However, you reduce it by 2, by 4, but eventually you're going to get the same answer. When you reduce it, you'll get the 1/4. Yeah, it's a shortcut to cancel. All right, now dividing is pretty much the same. Dividing is multiplication, guys, right? It's just flipping the second fraction and changing the division to multiplication, all right? So, like, how about this? If I were to say, side note, what's 10 divided by 2? What's 10 divided by 2? 5. Right? Now, if I wanted to, I could treat that 2 like a fraction, put it over 1. And then the first term stays exactly the way it is. The division changes to multiplication, and the second fraction flips. So 10 divided by 2 truly is the same thing as 10 times half. Right? If you do both on a calculator, you're going to get the same answer, 5. Right? Okay, so dividing by a fraction is really the same thing as multiplying by the reciprocal of the second fraction. And that's what it says up there. If you divide by a fraction, change flip. What does that mean? Change the division to multiplication and then flip the second fraction that you were originally dividing by. So right here, do we mess with the first fraction? No, stays the same. The division does change to multiplication, and what do I do with this guy? I flip it. So it becomes 5 over 3. And then it's your regular multiplication problem. So I can't cancel anything out. That means that when I multiply it, I'm not going to be able to reduce my fraction, right? So, and that's my final answer. So what's my answer going to be?
5 over 6.
5 over 6. Done. Easy peasy. How about number 2? What do I do with that first fraction? Nothing. I leave it exactly the same. This becomes multiplication. And then flip that second fraction. It becomes 3 over 2. Could I cancel anything?
Yeah.
A lot of people say, I want to cancel the 2's, but remember, they're both on the bottom. Remember, where does canceling actually come from? It comes from the same term up on top and the same term on the bottom. 2 divided by 2, that cancels out. 2 divided by 2 is 1. But you see right here, we don't have 2 divided by 2. We have 3 divided by 2. And we also have 3 divided by 2. You can't cancel out anything. So right here, you're going to just multiply top with the top, bottom with the bottom. You get 3 over 4, and a negative times a positive is a negative. So negative 3/4 is your answer right there. Number 3. Remember, the rules of multiplication and division are the same thing. What's a negative times a negative, or a negative divided by a negative? Positive. So you don't even have to worry about those negative signs. You know that your answer will be positive, okay? So let's rewrite our first fraction exactly the way it is, 8/9. Now the division becomes multiplication, and I flip the second fraction. When you divide by a fraction, it's really multiplying by the reciprocal of that second fraction. So that'll be a 33 over 4. Now notice I didn't even put negative signs. Why not? Because I already know a negative times a negative, or a negative divided by a negative, is a positive. So I don't even have to worry about it anymore. So what could I cancel here, if anything? Okay, look at something on top. Look at the 8. Yeah, the 8 and the 4, right? Top and bottom, top and bottom. So 8 and 4, you could divide both of them by 4. 8 on top divided by 4 on the bottom. So that's like saying, what's 8 divided by 4? That's 2. What's 4 divided by 4? That's 1. Now, even the 33 and the 9. Could I divide 33 by 2? No, because it's an odd number. Could I divide by 3? Yes. Yeah? Could I divide 9 by 3? Yeah? So that's what reducing is, right? It's dividing both top and bottom by that same value. So if you reduce that top one by 3, what will I have? 11. If I reduce the 9 by 3, what do I have? 3. So look at the numbers I have left over, and now go ahead and multiply the top with the top. What's 2 times 11? 22. And the bottom with the bottom? 3. There's your answer, 22 over 3. Now, that's what we call an improper fraction. When the numerator is bigger, you could actually divide and write it as a mixed number. You don't have to do that. On my quizzes, I'll accept that as a good answer. But if you wanted to, you could put the 21 or the 22 inside of the division box, the 3 on the outside, and say 3 times 7 will get you 21. And you have a remainder of 1. So you always put the remainder, this 1, you put it over the original divisor, 3. So you're going to put 7 and 1 over 3. So 7 and 1/3 is the same answer, but just written as a mixed number. Okay, so I hope we understand. I hope we understand how to multiply and divide fractions. That's what we're going to be working on the second half of class, and we're going to have that as homework if you don't finish the assignment in class. Now, there's one more topic I want to touch. It's called exponents, right? Okay. So, exponents are pretty easy. Exponents are really multiplication problems. This 2 we call the base, right? This little number up on top, that's what we call the exponent, or the power. Now, this little number up on top tells you how many times to multiply the base with itself. Exactly. So 2 to the 3rd is 8. Why? Because 2 times 2 times 2 is 8. As a matter of fact, when you take 2 to the 3rd and write it out, 2 times 2 times 2, that's what we call expanding. Yeah, 2 times 2 is 4, and 4 times 2 is 8. So that's why we get the answer 8. Now, before we move on to the other side, I want you guys to compare, write this down in your notebook somewhere. Compare negative 2 to the second power, but negative 2 in parentheses with the second power on the outside. And then write down, compare with negative 2 without parentheses to the second power. So many people think that they're the same thing. As a matter of fact, the first year I started teaching, I saw this problem and I'm like, oh, the answer is 4, and I was wrong. It's not 4. It's negative 4, right? So let's understand what these parentheses, what kind of difference it makes. See, when you say parenthesis negative 2, the parentheses include that negative with the 2. That's like saying negative 2 to the second power. So the base is the 2 with the negative. So I need to write that base 2 times. Negative 2 times negative 2. And what is negative 2 times negative 2? That is positive 4. Now, over here, we do not have parentheses including that negative sign. We do not. So we must look at the exponent first. This 2 squared, we must do that first, the 2 times 2, and simply bring down this minus sign and put it right in front of that problem. So what's negative 2 times positive 2? The answer is negative 4. You see, there's a huge difference when you put parentheses and the negative is included, as opposed to no parentheses and the negative is just out in the front. Okay? All right, let's move on. How about you guys write that down in your notebooks, and let's expand both of these with your knowledge of how parentheses affect it, or without parentheses, right? See, if I do the expansion, I have negative 2 times negative 2 times negative 2, right? Because the base is negative 2. The parentheses are including this negative sign on the 2. So when I work this out, negative 2 times negative 2 is positive 4. And positive 4 times negative 2 gives me the answer negative 8. Okay? Now on the other one, the exponent 2 to the third, that really means 2 times 2 times 2. The negative is not included when you repeat the base 3 times. The negative is simply out in front. It just comes down, you put that negative out in the front. Which in this case, it's going to be the same answer, right? 2 times 2 is 4. 4 times 2 is 8. Bring that negative down, so your answer is negative 8, just like this one. Okay? So I guess it does make a difference when you have an even power, because they'll end up pairing up. And it does not make a difference when you have an odd power. As a matter of fact, let's investigate that a little bit further. Let's say I had negative 1 in parentheses to the power of 8. What's the answer going to be? Okay, so let's think about expanding. Imagine this, negative 1 times negative 1 times negative 1 times negative 1. Man, it's taking too long. Now, yeah, when you pair them up, this guy times this guy is positive 1. This one times this one's positive 1. This one times this one's positive 1. And they all pair up, right? So you do end up with 1 times 1 times 1 times 1. No negatives. It's all positive 1, right? Why did they pair up? Because the exponent is even. Even means that it's divisible by 2. That means you're going to be able to pair them up into pairs. And a negative times a negative is a positive. So whenever you have negative 1 to the 58th power, I'm not going to write this 58 times, but I know that the power is even. That means I want to be able to pair them up, right? Which means that the whole thing is what? Positive 1. That's right. Now, what if it were negative 1 to the 57th power? Right there, it's not an even power anymore. So that's going to be a negative 1, right? Okay. What if I said this? What is negative 1 to the 28th power? What's that going to be? I tricked you.
No, negative.
Why? Why did I trick you? There's no parentheses. There's no parentheses, right? So what you're doing is this. You go 1 to the 28th. That's just 1 times 1 times 1 times 1 times 1. That's just 1. And then that negative sign is going to go right in front of it, right?
I said that.
Negative 1, yeah. Okay, so tricky stuff. It will appear on our test Friday. Please make sure you study. So let's flip it over to the back side. And I explain this exponent situation right here in our notes. Right? Negative 3 squared is positive 9 because you're including that negative sign. Negative 3 squared without parentheses, that's actually negative 9. And I even show you the expansion, right? Here's the example. Negative 3 in parentheses squared is really negative 3 times negative 3, which is positive 9. Negative 3 without it, it's just a negative in front with 3 times 3, which will give you a negative 9. So I'd like you guys to practice and do 1, 2, 3, 4, 5 on those exponents. Go for it. As a matter of fact, I wanna pause. I wanna stop the video right here, and I'll make a second video explaining all these questions. All right, but I do want you to go through and try to do this on your own. The answers are posted on the back wall if you want to take a picture of them so you could be checking your answers as you go. And you could also, I make mistakes all the time, so if you find a mistake, please let me know. But, I mean, check out what we're doing in class for the rest of the class. We're just adding and subtracting integers, right? Just remember, a negative minus negative, change to plus plus before thinking of money. We're also multiplying and dividing integers, right? A negative times a positive is a negative. We also have multiplication of fractions. That's pretty easy. Just multiply the top with the top, the bottom with the bottom. If you could cancel anything out, please cancel. Dividing fractions is the same easy thing, right? Now let's say number 17. 17 is so easy you might get confused.
Put negative 1, I mean, a 1 under the negative 4.
All right, you could put a 1 under the negative 4. And we're going to change the division to what?
Positive, and 1 times 2.
To multiplication. And we flip that second fraction. Remember, so that'll be 2 over 1 times negative 4 over 1. That's really just negative 4 times positive 2. Right? A 1 underneath, it's not even a fraction. So what's negative 4 times positive 2? Negative 8. Right? Multiply the top with the top, bottom with the bottom. If you put that over 1, you're still right. But anything over 1, you don't even need it over 1. So that's just negative 8. Right? Okay, so I want you to practice on all these. We also have more exponents down here. We also have some with negative 1. Odd, even exponents. I will make a second video explaining all these. Just in case you're absent and you want to check your answers from home, here are the answers. Just pause it on whatever one you need to see.